Let's have a look at this example of a question regarding scale factors. Part A says the ratio of the areas of two similar triangles is 1 to k. Write down in terms of k the ratio of the lengths of the corresponding sides. Well, we've got a relationship between areas. So as I go from one shape to the other, the area of the two shapes is linked by the ratio of 1 to k. So the area scale factor is k over 1 going that way. So therefore, the length scale factor is the square root of the area scale factor. So the length scale factor is the square root of k. And that is your answer. And that was part A. Let's have a look at part B. So in part B, we've got two triangles, APQ and ABC. They are similar because they have the same angles, because we're told that PQ and BC are parallel. One is just a size reduction of the other. We're given the length of the large triangle down here, AB is 10 centimeters, and we're told, and this is the crucial fact, is that the area of triangle APQ is half the area of triangle ABC. So that's giving us an area scale factor. So as I go from the area of the small triangle APQ up to ABC, the area scale factor is equal to 2. So therefore, the length scale factor also going from the small triangle to the large triangle, the length scale factor is equal to the square root of 2. That reflects our answer from part A. This means that any length on this triangle must be multiplied by root 2 to get to the equivalent length on this triangle. Now in the question, we've been told the length of AB, which is a length on the large triangle. So if we're going to convert this to a length on the small triangle, we have to divide by root 2 because we're going the wrong way. So we now divide by root 2 rather than multiply by root 2 if we're going from the small to the large. So therefore AP, which is the equivalent small length, is equal to 10 divided by the square root of 2, which is equal to 7.07106, and it goes on, of course, and that to two significant figures is 7.1 centimeters. And that is your answer.